Now this book section is about Euler circuits, pronounced Euler. And so we need to be very good at understanding the terms paths, circuits, and Euler circuits. And to start with, a path is any list of edges that you can trace with your pencil without picking it up. Any walk you can take inside of the graph. Now we need a good system of writing these paths down, and you can develop your own if you like, but I like this system personally. Here's a sample graph. I got 4 vertices, I got 5 different edges. Now, in order to talk about the different edges and describe the walk that we go on, I'm going to give all of the vertices names, A, B, C, and D. So what does it mean when I write A, B, C? My path is described by the code. This is like a secret code, A, B, C. Now, to me, that translates to we go from A to B and then from B to C. So as a movie, what it looks like is you're standing at the vertex A, and then you follow this edge over to B, and then you follow this edge over to C. That is a path inside of this graph. Here's another example. A, B, A, C, D. And what does that mean? It means you go from A to B, B to A to C, and C to D, and you stop at D. And so we're going to start at vertex A, you walk to B, you walk back to A, that's okay. You're allowed to go back over an edge that you just traced. And then you go down to C, and then you follow one of these edges to D. It turns out that it doesn't really matter which one we pick. So you follow an edge to D. Boom, that's a different kind of path. So then what is a circuit and what is an Euler circuit? A circuit is a special kind of path that ends where it starts. And that means that all circuits are paths, but not all paths are circuits. An Euler circuit is a special kind of circuit, and it's going to be one that covers every edge in the graph exactly once. Some graphs have Euler circuits and some don't. So ABC, this is the same graph from before, and ABC, the path that starts from here to here and then goes to here, that is a path but not a circuit, right? Because we started at A and we ended at C. However, if I added an edge to my walk, ABCA, looks like this. You start at A, you go to B, you go to C, you go to A. Well, that's a circuit, right? You ended where you started, at vertex A. But it's not an Euler circuit because we didn't cover all of the edges exactly once. These guys are sitting down here like, well, what are we, chopped liver? So what is an Euler circuit for this graph? Here's one example. There's more than one, but A, B, C, D, C, A. And this is what it looks like. You go A to B to C to D on one edge, and then you go back to C on the other edge, and then you follow this edge up to A. Now that is an Euler circuit. It covers all of these 5 edges exactly once, and you end where you started.